Couchy's theorem. It says if f of z is analytic on and within a closed contour or closed curve, we can say, then integration over the closed contour C f of z dz is equal to 0. This is very important theorem for the competitive examination, that it says if we have any closed curve and if the given function is analytic on the curve and within the curve, then integration over that closed contour is 0. Now what is meant by analytic on the curve and within the curve? That we have discussed, that analytic on the region means it must be analytic at each point of the region, and analytic at each point of the region means what? That function must be differentiable in every neighborhood of each point. Okay, so that Couchy theorem says if the function is analytic on the curve, that means if you consider the points on the boundary of the curve, that function must be differentiable, function must be analytic. Okay, and within the curve, if the function is analytic on the curve and within the curve, then the integration over that closed curve is always 0. Couchy integral formula. In the last we have discussed Couchy's theorem. It says if the function is analytic on the curve and within the curve, then the line integration over the closed curve is 0. Now here Couchy integral formula says if function fz is analytic on the curve and within the curve, except at z is equal to a, then function value at that point is equal to 1 upon 2 pi I integration over the closed contour C f of z upon z minus a dz. This is Couchy integral first formula, and the second formula is this one. I can say first, and second is if, that means this function is not analytic at this point. Okay, and if the multiplicity of that point is 1, then we have the Couchy's first theorem. If multiplicity of the point is more than 1, if z equal to a is a multiple pole, then we have the Couchy's second integral formula. Then suppose if z equal to a is a pole of order n, is a multiple pole of order n, then function value or derivative of the function, nth derivative of the function at a equals to n factorial upon 2 pi I integration over the closed curve C f of z upon z minus a to the power n plus 1 dz, to the power n plus 1 dz. So these two are the Couchy integral formulas, Couchy integral formula 1 and Couchy integral formula 2. If z equal to a is a point of singularity of order 1 or it is a pole of order 1, then we have the first formula, and if z equal to a is a pole of order more than 1, then we have the second formula. Very easy and very important.